One of my favorite tools is this one here called, we're going to get into imagery, which is another aspect of geotechnologies now. This one's called the Landsat Lens. So the Landsat Lens, Landsat is a joint project between the USGS and NASA. And it was conceived back in the late 60s. Like, hey, we're doing a lot of effort with, as you know, if you think about what was going on then, with the moon and exploring the moon. And eventually we're going to get people on the moon. And what are we going to do once we do that? But a group of scientists said, you know, we don't really understand all that's going on here on the Earth. So why don't we have a satellite that's just taking pictures of the Earth? And Landsat, or land satellite, was born. So it came around 1972. It was called the Earth Resources Technology Satellite, or ERTS back then, but was then renamed to Landsat. So with this tool, you have about 50 years of Landsat data at your fingertips. Not all of them are in this particular tool, but let's just say we start with Abu Dhabi, and we look at the difference between 15 years worth of satellite images. If I grab these little tiles and I look, as you probably are aware, Abu Dhabi, Dubai, and many of those cities in the UAE were just little fishing villages as recently as the 1970s. There wasn't much there. Okay, there's a lot of sand, and there's a couple of houses along the coast, and that was it. So in this case, we've got 2002 versus 2017. You know that based on examining this, that all of those developments offshore, they didn't exist in 2002, but they did by 2017. And then if I pan a little bit more over here to the interior, I can see that these vast stretches of desert in 2002 are now being developed, even this one area right here. So just with this tool, you could look at a place like not just Abu Dhabi, but notice the bookmark pick. You've got a small set of locations around the world in there, but you can also, in the upper left here of this map, you can look at Dallas or Denver or anywhere that you're interested in. I'm going to go ahead and go to Mount St. Helens because it's a fascinating example of the Earth is a dynamic planet, correct? And if I look at the crater in 2 different years, I'm still looking at 2002 to 2017, but I'm looking at natural color. And that's another fascinating thing about geotechnologies. In the case of Landsat, there are cameras on the Landsat satellite that take images in different parts of the electromagnetic spectrum. There are, as you know, a whole bank of wavelengths in the electromagnetic spectrum: ultraviolet, infrared, visible light. And as you know, our eyes can only see a little fraction of that electromagnetic spectrum, and at the other end, radio waves, and at the other end, X-rays. The microwaves, there's all kinds of electromagnetic energy out there. And the Landsat satellite, one of the things that it can take images of is in color infrared. So just a little past red, you know, Roy G. Biv. It's a little past red on the higher wavelengths. But if I took why are we taking images in infrared? The reason why, largely, is to look at healthy vegetation. And healthy vegetation in infrared shows up as a bright red. So if it's with our eyes, healthy green vegetation is going to show up in bright red here on these images. So we can look at, some of you may have been to Mount St. Helens. These are pretty big trees that were knocked over, right? They're not Colorado trees, as wonderful as our trees are. They're Pacific Northwest, big lodgepole pines and other things that were knocked over with the lateral blast in 1980, which is the most recent eruption, a major eruption. There's been other eruptions since then, but I can look at the changes over time, seeing the vegetation regrowing. And I'm looking at even 2002 versus 2017. It looks like in Spirit Lake, for example, that must have been yeah, it's a 15-year period, and you can even see the differences in the lake level, as well as in the vegetation and how it's regrowing with that wonderful abundant moisture that you've got in the Pacific Northwest. So I've got these little tiles. I could pick additional years, so I could pick 2010 also, and pan these little things around. Now, as I do this, if I scroll my mouse, I can actually make these tiles bigger. So I'm not just having, you know, a little postage stamp. I can actually make these tiles bigger. So it's just a wonderful tool. You can see it just, again, playing, you know, hey, I'm a geographer, and you can be a geographer too. You can look at this and say, well, gosh, you know, looking at the crater, the blast went to the north. This is oriented to where north is at the top, which is what most maps are, but certainly not all. But Here I can see, yeah, that blast went north because I can see the shape of the crater, and that whole north rim, if you will, is all caved in. It didn't exist anymore after 1980. And indeed, before that, it was a lot like Mount Fuji, right? It was a nice conical volcanic structure there. So, you know, using this tool, it's a regional tool, right? You can look at regions. You can't look at your own neighborhood, your own house, your own, you know, driveway, your own library, or you know, local place where you go shopping, etc. So what would we do if we wanted to look at things in higher resolution, but not having all of these choices on the parts of the electromagnetic spectrum? Well, as a matter of fact, we have something that you can use to do that, and that is the historical satellite imagery. It is something from the Living Atlas of the World, which is a compendium of about 8,500 maps, called the Wayback Imagery. Wayback Imagery. Now, this is higher resolution, as you can already see, imagery, but again, you've got, just like the Landsat Lens, you have global coverage. So you've got the, right here at your fingertips, the ability to do the following. If you get it, when you get into this tool, you want to go over here to the left side and say only versions with local changes. That's only going to show me a subset of the number of images in here, but now I'm only looking at things that show change over time. And the default view that comes up is, as you probably suspect, is a place that's fast growing. You could probably hypothesize where this is, and you might want to put it in the chat box. Where do you think this is? Now I'm taking a look at 2014, and then I'm going to switch it to 2020, and I can see this freeway coming around here. I can see this really dry terrain here. Doesn't look like there's any trees at all there, but we've got this major city out in this really semi-arid area. Where might this be? Okay, I'll keep an eye on the chat box, but look at the changes. And if I pan over here to the east of this city, I'm looking at this body of water now. And then another thing, which is what I want to foster when you're looking at these data sets, is you want to question what's going on and why. So if I look at 2014 here, and I see 2014, and then, there's something changing here. Look at 2020, that little preview, and then 2014. The lake level is dramatically lower. And some of you know this lake. It's, yeah, thanks, Jason. It is Las Vegas, and this is Lake Mead, which is actually a reservoir, correct? But the point is the lake level has gone down. So again, the whys of where, what's where, why is it there, and why should we care? Okay, we're in a multi-year drought here in the west and southwest. And so what implications does that have? Does Las Vegas and other cities have enough water to sustain this kind of massive growth that we've had in places like this over time? Even at this scale, you can see the differences between 2014 and 2020. Especially in the northern part of the city and also in the southwest that we were looking at. Look at 2014. It's there. It's on the alluvial fan up there in the northern part of the city, and then in 2020, there's a lot of that's filled in. We think we have some rapid growth here in the Front Range, and we do. But you know, you take a look at North Dallas and Las Vegas and places like that, and ditto for a lot of world cities internationally. Okay, but fascinating. With this same tool, you could look at coastal erosion in England, agricultural expansion in Saudi Arabia, Abu Dhabi, the Three Gorges Dam in China, glacial retreat, urban sprawl, agriculture, deforestation and reforestation. There's all kinds of things you can look at with this tool. So here's one of my favorite landscapes. I've been to it a few times. It's part of the Chalk Cliffs in England. This is Eastbourne, and you can see here from 2020, see this set of row houses? Okay. And then look at 2014. The coast is retreating. This is Chalk Cliffs. It is a rapidly eroding kind of beautiful area, but I'm not sure I want to live right there. In 2016 and 2020, yeah, so you can see that the coastline, even over 4 years, and indeed here's the visitor center, and they have some lines in the floor of the visitor center saying, okay, in 2050 the visitor center is not even going to be here. We're gonna need to relocate it based on current rates. So, you know, this is an example of the Earth is a dynamic planet, and we've got these mapping tools to be able to understand how things are changing and why things are changing, and perhaps can we do something about it. Okay. Fascinating. So global tool at your fingertips called the Wayback Imagery Service. Fascinating. Okay, again, this is an example of something we could take a look at. I'm going to show you an example of what you might want to do in your local neighborhood. So here we've got, you can type in an address up here. Okay, so here is our former office up in Broomfield. So I've got a 2014 image here. You can see that there's this massive apartment complex that was built, and it was largely done by 2019. So even in our own neighborhoods, we can see changes. Unfortunately for us, it took out our view all the way up to, pretty much all the way up to Fort Collins. We had a hill there, and the apartment complex got it. Admittedly, it's a nice view and it'd be a nice place to live. So that's up at Interlaken in Broomfield. You know, you can see US 36 off here to the north. So 2014 to 2019, some changes. You can also see a new building going in, a new office building in this case over here, between those 2 years. So you can do the same thing for your own neighborhood. What's changed, or a neighborhood that you grew up in. Now, with this set of images, you do not have 40 or 50 years of change. You've got roughly 6 years. But stay tuned. All of these tools change. They become more powerful, they become more useful, and gradually data is added to them. Now, just as a note, oftentimes we get some students, for example, that would say, hey, Joseph, can I get a satellite image from like 1850? No, you can't. We didn't have any back then. And so, you know, it's kind of like those people that email their public librarian and ask for a photograph of, I don't know, George Washington. There's no photograph, okay? There's a drawing, paintings, but okay. So that being said, all of these have their limitations in terms of their years and their spectral bands and electromagnetic spectrum and so on. But still, that all being said, you do have a lot of fascinating things. What if you did want to go back a little bit farther in a certain part of the world? Well, that's why I have these USGS topo map web mapping application in here. And for you and I that love looking at space, change over space and time, I think this is fascinating. So it starts with New Orleans. This is only US because it's USGS topo maps. And that program has about a 100-year history. And so let's say we want to go to Morrison, Colorado. You can do the same thing on your own right now where you are. So if I take a look at Morrison and I click in here, so I'm going to actually pan up to I-70, where I-70 goes into the mountains at the Hogback. Look, I've got this timeline below the map with all kinds of different scales, so depending on what map scale you want to look at. But look, I've got a 1938 and a 1942, and look, I've got a 1947. This 1938 is at 1 to 24,000 scale, which is my favorite scale and probably the most commonly used one out in the field because it is the most detailed. But if I look at 1938, so here's the Morrison topographic map, and you can see here, this is the west side of Denver, right? So if you wanted to go into the mountains back then, I-70 didn't exist. You had to go west on US 40, and there's also US 6 coming in here, and you had to go in by the old, where Heritage Square used to be, for some of you that know that. Then you have to bend to the south, and then you go up Mount Vernon Canyon. Now, look, you've got the map over here on the left side, and you've got a little transparency tool. So you can make this a little bit more transparent, and you can see, oh, I-70 was blazed right through the Hogback, and it makes sense because of physical geography that they routed it up Mount Vernon Canyon. That was the best way to put it. But we didn't want to have that big bend over there on US 40, so we decided to go right through the Hogback. And of course, that resulted in that wonderful road cut that you can go visit. And then another thing is you can start looking at the urban changes as the growth, the population growth from Denver actually reached the front of the mountains right there. So being able to look at, okay, we've got this, I'll just leave it right there, and I'm going to pan a little bit south, and I can see some of the urbanization from on the south side of Green Mountain on the west side of Denver coming in. It didn't exist in 1938. Red Rocks Park was there under construction. And you know, from the work project that went on in the 30s there, and you've got that road out to it. But Alameda Parkway, that was pretty much it, and Mount Vernon Canyon. So, what do we also? We've got a 1980. Look at this. We've got a 1980, and one of the reasons why I like to show this one is that it actually shows 2 different years, even though it says 1980. It's got urban tint on it, and these tints are in pink from the older 1965 map in this case, but then the newer tints coming in from 1980. So the 1980 photo revisions were in purple, and the 1965 urban area is this pink over here on the east side. So we can see here that now we've got a 1938, a 1965/1980, and then a modern day, if I make all these transparent, this is the modern street base. So with this, again, you can look at all kinds of interesting places. USA only, because this is a USGS topo map interface, but shown at its cooperation, as you can see, the two agencies working on the topo map viewer, my organization and my former organization, both collaborating to create this. So you've got 75,000 USGS topo maps at your fingertips right here with different years. Yep, pretty amazing stuff. All right, I wish I could get excited about this. Isn't this just amazing that you've got this stuff? I mean, you can look at, your old hometown and where your grandmother grew up and all kinds of things. And why is, Denver rapidly changing, but St. Francis, Kansas, you look at the 1950 topo compared to today, and there's not a whole lot of change. So again, the whys of where. Why do people migrate and settle in certain areas? Remember last week we looked at the amount of people in each state and how many people were born in that state that they now reside in, and in discussing migration just a little bit.